This is a second section of the real-time streaming using Apache Streaming, and in this section we'll be implementing the streaming processing using Apache Spark Streaming framework. Firstly, we will see how to handle infinite unbounded stream of data. We'll be using the event time and processing time, and we will see how they differ and why. We will be sorting stream data. We will implement the duplication of data, because most data source messaging systems work in at least once delivery guarantee. This is the first video of the second section. In this video we'll be handling unbounded data. So, what unbounded data is? This is a question that we need to answer. Second thing is how stream processing is different from batch processing. Lastly, we will see why processing of events needs to be really fast. Let's look at the example of unbounded data. So we have an input data that is an infinite stream of events. We are constantly getting events from it. There is no way to pause the arriving events. So our processing needs to be reliable and fast. Let's say that we have batch of 1 second of events. In that case, our processing needs to be able to process those events in at most 1 second time. Otherwise, we will have a lag. If the processing of the 1 second batch will take 2 seconds, each processing adds 1 second of delay. After a couple days, we will have a lag in processing of events. We will be buffering the events that aren't processed yet until there is no memory to store them, and our app will crash with out-of-memory exception. In case of failure in processing events, sometimes it's not possible to retry. Sometimes when we fail to process one event, it is better to not pause or abort processing, but keep going with processing arriving events. Only save information that something went wrong while still processing rest of events. Failure of one event, if we need to process 100 or 1000 of events per second, is not a big issue sometimes. We need to be prepared of out-of-order events, duplicates, and lateness. We can get an event that is even from yesterday. So, processing needs to be very fast. We can tolerate specific latency. If we need to react very quickly, in seconds or milliseconds, we need to implement processing differently and make most of the work in the asynchronous way, and try to leverage as much resources as we can.